thoughts with you today. So without any further ado, we'll get started. The first thing I want to do is sort of highlight a brief overview of what we're talking about. This is the Amazon Web Services platform. You can see there we've got underpinning our global infrastructure, a large variety of regions. Most recently, the Sydney region has been opened. Each one of those regions has a number of availability zones, and we also have our content distribution edge locations as well. The key things I wanted to talk about today are within the storage foundation services, most particularly S3 and Glacier, just to give you an idea of where this fits within the overall AWS offerings. The storage services, as I said, Amazon S3 is a redundant high-scale object store. Obviously, we've also got Amazon Glacier, a low-cost archive storage in the cloud. And while I'll talk about Storage Gateway, I'll skip over Elastic Block Store for today's presentation. First up, I wanted to get a couple of sort of common definitions out the way. A number of you may not be sort of fully up to speed on object storage. Just some of the storage basics. Obviously, most of us are very familiar with block storage, where you have a host file system placing the data on the disk, typically something like NTFS or ZFS. And Gartner forecast that structured data to grow at 18.7% over the next few years. File storage is unrelated data blocks. A native file system places that data on the disk, and this is an area of large growth for a lot of customers. We're seeing forecasts up to 47.3% compound annual growth rate. I guess the new emerging storage model is object storage. Typically, object storage isn't managed by a file system, it's self-managing. And rather than using a file system to access the storage, typically you use APIs to the data. That means it can be very performant and also scales very, very well because you have no host overhead for storage functions. And essentially the concept of, let's just take care of that there for everyone. The concept of object storage, you have the concept of containing a number of objects in a bucket. So S3 obviously presents buckets to users, and within those buckets, users are able to place objects, and those objects obviously have object IDs and a variety of metadata associated with them. This becomes more, I guess, relevant when we talk about the proximity of the storage, and so typically block storage is presented in a SAN utilizing fiber channel or iSCSI. Can be very performant, very high speed, and typically within the same data center. Additionally, also similar with NAS for file systems, for file storage, typically presented as an NFS or CIFS interface, and that would be the sort of degree of storage that most people are familiar with. One of the benefits of cloud storage or object storage is that it's, let's try that, is that it's able to be shared over the cloud. And so, as I highlighted earlier, object storage is accessed via a series of APIs over HTTPS or HTTP. And so what that means is your storage can be remote from your processing and obviously scale a lot greater. So what are our customers telling us? Look, one of the things we're seeing from a lot of customers is data growth is spiraling out of control. And so essentially at all levels, both file, block, storage, and customers are really struggling with the enormous amount of data growth, and seems to be occurring for sort of two key reasons. One, users are creating a lot more data, so you get the concept of people creating large multimedia PowerPoint presentations and the like, sharing those via email creates all kinds of storage problems. And then we're seeing emerging new storage use cases where we're seeing large amounts of unstructured data that previously hasn't been useful to organizations now having a real value and having to be captured and stored, particularly when you think about things like CCTV information or the data associated with utility metering and the like. And that is then fundamentally confronts a problem around traditional technologies. They simply don't scale. I know that when a lot of CIOs I talk to try to accurately predict their storage needs, inevitably they get it wrong. And getting it wrong has a cost. If you're getting it wrong by under forecasting, then you have a service impact. And if you get it wrong by over forecasting, while you don't have a service impact, certainly you have a capital underutilization, and that can be just as prohibitive in terms of these days of tight budgets. And what that then means is cost becomes a real issue. SAN systems are very expensive to scale. Archive hardware and software is very expensive. Tape is very unreliable, or can be unreliable and cumbersome. I certainly don't hear a lot of people saying I'd love to do more tape. Certainly we hear a lot of people coming to us and say, how do I get rid of tape? And then multi-site collaboration as people seek to get redundancy and durability of their data can often be very challenging. These are sort of a sample of some of the things. And so what that's seen is a proliferation of a wide variety of solutions for different on-premise use cases. So obviously most companies have their primary block storage, their primary file storage. Additionally, they have archival storage and disk-based backup. They'll have tape infrastructure and management, or outsource that to a third party. That will all be replicated for disaster recovery, and then you'll obviously have off-site locations. And the CIOs I talk to are always coming to me and saying, look, just what's next? Because this complexity becomes an inhibitor to delivering great service to the business. So obviously the service I'm here to talk about today is S3. It's our simple storage service. As I highlighted earlier, it's an object store, we assert that S3 is scalable, reliable, fast, inexpensive, and simple, and I'll just take you through some of the proof points around that. In terms of scalable and fast, we've seen astonishing growth with S3. As I highlighted earlier, the atomic unit of S3 is the object, and we've grown from billions of objects, tens of billions, to hundreds of billions, and then in March this year we hit over 1 trillion objects. I note that overnight Andy Jassy's keynote at our reInvent conference has now taken that to 1.3 trillion objects in S3, and certainly the scalability of S3 is astonishing in terms of being able to provide storage for all of those objects. Additionally, in providing storage for those objects, you have to be able to serve them back to users as well. And so the peak requests in this slide 650, but overnight the new high is 850,000 requests per second served in S3. So in this instance, you can see how S3 is very scalable. It's scaled very large and also very fast. And the other key characteristic of S3 is its durability. I highlighted earlier the concept of availability zones within regions, and can be thought of as clusters of data centers. And so by replicating your object around those data centers within that region, we're able to provide 11 nines of durability. For those of you that aren't aware of durability, durability is the likelihood of when you put something into a storage system of being able to get it back again. Now, a lot of people might assert that that's 100%, but just talk to our friends that have ever lost data and you'll very quickly realize that that's not the case. Also, too, 99.99% of availability of objects over a given year. And you can see the statistic there, that if you put 10,000 objects in S3, you can statistically expect to lose one object every 10 million years. Very, very durable and very reliable. Some customers have come to us and said, look, I don't need this kind of reliability, I don't need this kind of durability. Are we able to pay less for less durability? And so we've, based on customer feedback, introduced a service called Reduced Redundancy Storage, which reduces the cost by simply storing the object at lower levels of redundancy. And it's very useful for utilizing storage. It's very useful storage for utilizing content and sharing content that is stored elsewhere. And Reduced Redundancy, although it's an interesting name, still provides 4 nines of durability of objects over a given year. In terms of security, very important. Amazon treats security as #1 priority. A lot of you will be familiar with the Identity and Access Management Framework. Those are the tools that we provide users to implement security around their AWS accounts. It allows customers to create and manage multiple users and gives fine-grained control over S3 buckets or objects. Additionally, we provide access control lists where administrators can add or grant certain permissions on individual objects, and obviously also bucket policies where you can do the similar thing at a bucket level, and those objects that satisfy the criteria within those policies within a bucket are also subject to those policies. For the web-based stuff, we talk about query string authentication, where you're able to use timed URLs and obviously for limited access to buckets or operations on those buckets. Encryption is a very important aspect of S3. We provide server-side encryption where the customer is able to either using an API call or using a console automatically encrypt both buckets and their contents. We also provide an S3 encryption client where you can encrypt your data before uploading it to S3 and manage those keys yourselves. Several of our ISV partners also do similar things. And so we have this concept of where you have data encrypted at rest, both on the client premises and at rest within the Amazon cloud, and also in transit utilizing SSL. I think the final security measure is logging. All operations against S3 and a customer's S3 buckets are captured in logs. Those logs can be stored in a separate secure bucket with admin-only access, or they can be indeed exported to a customer premise. I would say, though, that I see a lot of customers capturing logs, and the security policies are generally best when those logs are regularly audited and inspected for unusual activity. In terms of inexpensive, the final sort of criteria we're talking about, I'm delighted to announce that overnight we reduced the pricing on Amazon S3 by around about 20%. And so this pricing is now out of date. US standard, I believe, is now down to 10.5 cents per gig, and reduced redundancy also reduced a similar amount. What Amazon does is where possible, where we gain cost savings through increased efficiencies or technological improvements, we pass those savings on to customers on a regular basis. And you can see there that we've had 24 price reductions to date. That may be out of date now with our new latest announcement, but certainly over the long period, we continue to provide great value for customers by continually reducing our prices and ensuring that we offer a competitive service. In terms of simplicity, if you think about the benefits that Amazon S3 provides, customers are now able to eliminate the need to manage storage. There's no need to back up. There's no need to rack and stack storage disks or servers. Simply, those requirements simply go away. And we at Amazon refer that to as that to undifferentiated heavy lifting. An IT department performing those functions isn't really adding value to the business. There's very few businesses where you could say the ability to install servers quickly is a material value add to the business. Additionally, too, we talked earlier about customers and IT managers forecasting usage with Amazon S3, because it is effectively limitless storage for customers. You also remove the need for that. And additionally, you get much better cost efficiencies where the pay-as-you-go model where you only pay for what you use rather than pre-purchasing a set amount of storage, say 100 terabytes or the like. You only purchase what you use as you use it. And indeed, with our business model, when you delete it, you no longer pay for it. So you look at those sorts of business model impacts and the technological impacts of the scale of the storage, and allows IT departments to really focus on the business, not on managing the hardware or the technology. The next service I want to talk about was Amazon Glacier. Amazon Glacier is really based on response to customers' requirements in the way that they asked us for a lower durability on S3. Customers also said, look, I don't need the high performance of S3. I don't need the ability to retrieve files instantaneously or at high volumes. Is there a cost saving we can make whereby we might not, say, have the data for 4 hours, 5 hours a day? And so out of those requirements, Amazon Glacier was born. And Amazon Glacier still provides the same 11 nines durability over a given year as Amazon S3, but the response time is 4 hours. So when you put a file or an object into Amazon Glacier, it essentially takes 3 to 5 hours to complete the upload, and the same as for the retrieval. When you are retrieving or implement a retrieve command on Amazon Glacier, within 3 to 5 hours, that object will be returned to the staging area for you to either transfer into an S3 bucket or download to your own premises. By implementing that level of latency, the 4 hours, we're able to offer 11 nines durability with a 4-hour response time at 1 cent per gigabyte. So this means now that customers are really able to look at putting long-term, high-volume workloads on Amazon Glacier. Obviously, with the 4-hour response time, it's not intended to be a high I/O service. It's not intended for customers to do lots of downloads. It's the kind of service. It's a deep archive service. It's a service you would use if you're unlikely to ever want to retrieve that data, obviously barring disaster or the like. And so what we're seeing is Amazon Glacier is becoming a key part of our customers' tape replacement strategies. This is a solution architecture diagram here. A couple of things to note. Obviously, Amazon Standard Glacier also falls under the Identity and Access Management. It allows customers to send and receive data from their data center to Glacier. And a couple of other things to note here too. The smallest atomic unit of Glacier is an archive, rather than a single file as an object. And an archive obviously may contain many files, and the customer is required to maintain their own metadata or index of those archives. The maximum archive size is 40 terabytes, and customers are able to upload those archives to Amazon Glacier. In addition to that, we've also recently announced a function whereby we archive objects from within S3 to Amazon Glacier, a so-called S3 archive or S3 Glacier, where a customer is able to take advantage of their S3 buckets and the policy interface and apply policies that act on buckets and the objects within those buckets and shift them to Glacier effectively. And so you could apply an archive policy whereby you say for everything in this bucket that's older than 30 days, shift it to Glacier. And what that does then is that allows the cost of storing that object from, say, around about 10 cents per gigabyte in S3 to 1 cent per gigabyte in Glacier. And so we're now starting to see the emergence of a tiered storage model within Amazon Web Services. And you can see it here where you have your reduced redundancy for your active hot data that you're working on. You have your midterm normal redundancy, 11 nines durability, from which the short-term information is drawn, and then the low activity, deep archive, longer-term vault in Glacier. And all of these services are obviously accessed both either through our console or APIs and various third-party tools. And so in terms of the options for interacting with S3 and Glacier, look, we obviously, as I said earlier, produce APIs and publish APIs for all of our services. And then along with those APIs, we also publish a number of software development kits for some of the popular languages you can see there. Interestingly enough, too, we have a very thriving, strong and thriving partner community, particularly around the ISVs, who integrate these services and into their appliances and or software to drive a number of use cases. I just wanted to quickly skip through some of those use cases now and settle on a couple of the more detailed ones and provide some third-party examples where a lot of our partners are providing solutions in this area. The first use case I wanted to talk about was thin SAN storage. You'll recall earlier we talked about SANs on-premise being high performance storage workloads. One of the key issues we're seeing is those workloads or those storage areas are becoming overburdened, and customers are looking for ways to back these up or not have to expand to the next level or upgrade to the next architecture level of SAN storage. And so by putting a gateway, an iSCSI gateway generally, on-premise, and in this instance the Amazon Storage Gateway, we're able to provide effectively a drain for the SAN and archive the information off to the cloud. We've got a number of models around this. The most popular is the Cached Volumes Gateway, whereby essentially the Amazon Storage Gateway maintains a list of what's available in the SAN, but a lot of that, depending on age, is archived into S3. Essentially what that does is it takes the pressure off storage expansion requirements around the SAN, and also because of the high degree of durability within S3, it eliminates the need for data backup and off-site backup as well, because we take care of that as we replicate that around our various availability zones so that customers don't have to. Another use case is thin NAS storage, where the NAS gateways are presented as a file system, and typically here you will see the vendors such as Panzura or Twin Strata, where those customers are actually presenting the file system locally. These gateways may have local cache storage as well, and manage the transition of the files based on frequency of access, either storing them locally or archiving them off to S3. Note that these are still visible to users. It's just that the ones that are archived that might not have been accessed for a while will take a little bit longer. But once again, by being able to do this, we eliminate backup software, we eliminate archive software, and essentially allow customers not to run out of capacity. Another use case for thin NAS storage is this concept of a common file system. This is where, by utilizing a metadata overlay, customers are able to essentially synchronize object stores within the cloud. Well, what I mean by that is that if I'm, for example, in London and a colleague of mine is in Sydney trying to access the same file, the metadata that's shared across these gateways is what essentially replicates the functions of a local file server, that is, enables file locking and the like. And essentially what you have here is a globally visible file system accessible to all, replicated within Amazon S3. A very, very powerful use case, and for distributed organizations, this is something a lot of them wrestle with all the time. I wanted to quickly talk about Tapeless Cloud Backup, and this is where the local servers and indeed the local backup management software still writes to a local device. Typically, most backup software will write to a CIFS NFS or an iSCSI device, but the backup gateway that they're writing to, which is presenting an iSCSI, whilst it maintains some local storage, typically archives a lot of it off to S3. And so essentially what you're getting here is a secure cloud backup without the need to having to write to an optical or media drive, so that you're not having to mess around with tapes and manage either the storage requirements locally or outsource that to a service provider with appropriate chains of custody and the like. Essentially, this allows customers to have almost limitless backup capacity and takes a lot of pressure off around the various structures and processes that are put in place around daily, weekly, monthly, incremental, and full backups. These gateways are able to run in the background, essentially to what looks like a limitless hard drive. File archive is another one. Essentially does a similar thing, where the gateway essentially runs the archive software. Once again, as I highlighted, in this case, an NFS or CIFS interface. It also, because the gateway will be able to handle an incremental backup, reduces backup times. You're not having to write to media. You're able to write to generally SSD on the gateway, and then over time that will drain to the S3 bucket as well. One of the next ones I wanted to go into a little bit more detail is Tapeless Cloud Backup. This is where instead of selecting, as I highlighted earlier, instead of selecting a tape or tape library, we are able to put in this case, a Panzura device on-premise, and that manages the deduplication, compression, encryption, and also throttling of the WAN, storing that into S3. You can see some of the figures that are claimed there. Certainly the ingest rates are very high, particularly with deduplication. This can also be set up as an automated process. So you remove the potential error caused by human handling, and obviously with S3 it becomes infinitely scalable. So this is a great solution for customers that are really struggling with what to do with backup, and more importantly, what to do with all their tapes. While a lot of these companies obviously have written APIs to S3, Glacier has only recently been released, and a number of these companies are actively working on Glacier-based solutions. Riverbed's another one, in this case utilizing the Riverbed Whitewater appliance. Whitewater is a WAN acceleration device. Essentially what that does is that sits on the cloud side of the backup server with optional disk or tape drives associated with it. And customers can, for example, in this instance, do a hybrid model whereby they may choose to keep a week's tapes on premise, but then drain their backup server into the cloud via the Whitewater WAN acceleration gateway directly to S3. This is quite a popular model with a lot of customers. Symantec have, with their Net Backup 7.5, now are able to select S3 as a target backup device, and in this case, we're able to obviously select any of the regions, also Sydney, which isn't here yet. The slide hasn't been updated, but essentially this is S3 integration into one of the most popular cloud backup software suites available, and also Oracle. So as part of their Oracle Secure Backup module, Oracle RMAN is now able to select S3 over a secure connection into as a backup target from the Oracle database snapshots. There's a large opportunity here, market opportunity. We're seeing a lot of customers express some interest in this. Essentially, once again, the popularity of, or the appeal of eliminating tape is quite a large one for a lot of customers. Finally, Commvault. Commvault, obviously, as a sort of storage management console, is also able to, across backup and recovery, archive, replication, and search, is able to select S3 as a backup target. And so they provide a unified platform which provides essentially the entire on-prem and off-prem storage management. In this case, with a non-Commvault right, that encryption is not integrated, so that no dedupe or typically, if you're a do-yourself, no dedupe or encryption. With Commvault, you're able to take care of that in one console, and it becomes very convenient for customers to do this. So I guess to summarize then, in terms of the benefits of AWS storage, it's a significant reduction in capital investments, and that occurs in a number of ways. The first one being you don't need to forecast your demand up front and make a capital bet on what that demand will be, because one of the things I've learned is over time most of those forecasts are either wrong, either under, or they're over. And as we highlighted earlier, if they're under, you have a service issue or a very expensive fix to get storage in time, or if they're over, then you have excess capital tied up in storage that you're not utilizing. And the ability to efficiently utilize storage has been a dark art in the past. With Amazon S3, it becomes a lot easier because you pay for only what you use. It's a metered utility. We don't think about provisioning a light switch when we go into a room to turn on electricity, to turn on the light. It's a very similar model here where with storage you're able to just use it as much or as little as you need to. And so that eliminates the need to over-purchase. And as we also highlighted as of this morning, prices continue to fall over time, so this stuff becomes much more competitive on an ongoing basis. Amazon is a company that operates on very low margins and high volumes, and we're comfortable doing so. In terms of operational, there's a dramatic simplification. Data management and data center operations are streamlined and simplified. In fact, you're able to eliminate a number of data centers. We have a customer in Australia who has gone from 3 data centers and in 9 months to none, and having everything in the cloud, and making enormous savings by doing that. It also allows IT managers to focus their employees on proactive tasks, solving business issues, rather than simply doing, as we highlighted earlier, the undifferentiated heavy lifting around racking and stacking. And finally, for the business, it's really, it allows the business, the IT department, to be a lot more responsive to the business. I was talking to a customer recently who was putting in place a new web-based application. They weren't sure of how successful it was going to be. They went to their IT department, who quite justifiably asked for a forecast. They said, look, we think it's between 20 or 200 servers. We're not sure which. Obviously, that kind of workload lends itself to the cloud. One of the things I can tell you is that it is between 20 and 200 servers, but it's on the high side of that. Essentially, what the storage systems and storage solutions offered by AWS allow is allow customers to continually innovate and turn IT from being a potential restrictor of innovation into actually being an IT enabler. That's the extent of the presentation. I'd like to thank you all for listening, and I think we've got some time for some questions. Okay, how do we do with the questions here? Here we go. Okay, I'll just quickly jump back to the top of the questions. Do we use any network flash appliances? In terms of the storage gateways, a lot of them come with flash. They do so to improve the on-site or on-premise caching. They come with a variety. Also, too, they scale from very small to very large. If you look at something like the Twin Strata gateway, they go from a virtual machine all the way up to a multiple rack unit with up to 80 terabytes of SSD, I believe. So that's something that each individual ISV takes a position on. Others go for cost and non-SSDs, but typically where they're looking at iSCSI replacement or iSCSI or SAN replacement or thin SAN applications, the SSD performance is required. In terms of the speed of S3, I probably didn't cover it during the presentation, but S3 is very, very performant. By that I mean it scales horizontally, so you're able to ingest millions, if not billions, of objects. We highlighted that there were 1.3 trillion objects in S3. I had a customer in Australia recently who ingested some 2.5 billion objects over 3 days. They were achieving peak writes of around 15,000 writes per second ingesting into the US. It's very performant. It's able to scale with a little bit of editing of keys and partitions, able to scale very, very highly and goes very, very fast. In terms of cached volumes, how do we cache them? The AWS Storage Gateway is presented to customers as a virtual machine. It runs as a VMware image and presents an iSCSI interface to the network, and then you have to provision storage on that machine. That storage is provisioned in 2 areas, one as a buffer for upload, but 2 as a cache. And so with the cache volumes of Storage Gateway, essentially what it presents itself as, by utilizing S3, it looks like, to all intents and purposes to the server, like a 32 terabyte cache disk. And so it's indistinguishable in terms of how it presents itself. It simply presents as an iSCSI device with high numbers of terabytes. Okay, just a question here about PCI compliance. I can certainly talk about that. We, as at Amazon, obviously we take security and the various compliances very seriously. We have PCI DSS compliance certification, and in addition to a number of other certifications. The best place to check out all that information is aws.amazon.com/security. The compliances we have are, like I say, very rigorous and thorough. We have SOC 1 Type 2, and we also comply with a lot of the other sort of Tier 2 compliances like HIPAA and FSMA and the like as well. Okay, I have another question here. Can we maintain a day-to-day backup of database and application on AWS? Absolutely. There's a number of ways you can do that. Obviously, the most simplest way is to run your database and application within AWS, whereby you utilize our RDS service. At the moment, I have a blog that I run on that. I call it my world's most highly available WordPress blog, where using CloudFormation, I've spun up different tiers, application, web application, and database. All of those are automatically backed up. I take snapshots of the database. On-prem, utilizing Oracle RMAN, absolutely. Oracle RMAN snaps to S3, as I highlighted earlier, and then you could back up your application images either as a full VM or as specific application snapshots as well. That would require either a separate backup system. I don't believe that RMAN takes the entire application. I do believe it just does the database state. Right, what S3 tools do we suggest on backing up files? There's a wide variety of tools. Look, the ones I highlighted are the sort of more enterprise level ones, but there are a wide variety from things like Panic's transmit application, TNT Drive, a wide variety of third parties scaling from very small to very high. I suggest that those are interested, check out our ISV partner list on our aws.amazon.com site. It is a veritable treasure trove of partners because all of our services are accessible via APIs. We see a lot of development of things from very small utilities, Cloudberry and the like, right on up, as I highlighted, to things like Oracle developing RMAN backups. In terms, do we offer a write once, read many feature? Yes, with Glacier, the archives are immutable, that is, they can't be overwritten, and obviously with the appropriate degree of security can be deleted. But certainly, once they're up there, they're immutable. You need to add another version or another. If that archive changes, you need to create a new archive rather than simply add to it. How much size can store on a S3 on a single file? On a single object, we're able to store up to 5 gigabytes on S3. And on Amazon Glacier, the largest archive size is 40 terabytes. Are there any plans for Storage Gateway to support other interfaces apart from iSCSI? Pardon me, I apologise, I misspoke. The object size on S3 is 5 terabytes, not 5 gigabytes. My apologies. Any plans for Storage Gateway to support other interfaces apart from iSCSI? Look, we're always taking customer feedback on that. We selected iSCSI because it seemed the most popular, but we are aware, obviously, that CIFS and NFS does exist. Look, I would say, look, we always take customer feedback and watch this space. It's something that we're evaluating. I really can't say anything more at this stage. I've also got a question around, for 5-hour retrieval response on Glacier, do you get any timeout issues with net backup? That's an excellent question. Currently, net backup doesn't automatically back up to Glacier. All of those use cases I highlighted were to S3. So what that means is that all of these ISVs, all of the independent software vendors are currently working on Glacier implementations, and obviously we'll see what they come out with. But certainly, right now, we don't get any issues because it doesn't write to Glacier; it only writes to S3. All right, what are the bandwidth options or requirements do we see being used for backup purposes? That's an excellent question. What we're seeing is a number of customers typically have, we see use cases in a number of ways. Typically most customers have a high volume upfront first time ingestion. Oftentimes customers will use a service like our import-export service, whereby you're able to ship us hard drives. I know in this day and age of high-speed networks and the like, shipping hard drives via courier seems somewhat mundane and old-fashioned. But as I think Werner Vogel said, never underestimate the bandwidth of a FedEx courier box. And so we've got customers very successfully utilizing our import-export service, particularly in Singapore, where people utilize that as part of their ongoing processes to do large-scale ingestion. It's also very valuable where customers are either a long way away from Amazon or in a poor network situation. Otherwise, we see other customers like Shell, for example, connected to us through our Direct Connect service. Our Direct Connect service is where we expose connection to the Amazon region in our most recently launched region in Sydney. That's at Equinix. And customers are able to purchase a 1 gig or 10 gig port to us. And once again, we charge for that by the hour. So I believe 1 gig is 30 cents per hour and 10 gig is $2.30 an hour. And what that does is it enables customers to do a couple of things. One, if they want to run a VPC, a virtual private cloud, direct to us. But more importantly, it means that they are able to get much more predictable latency and bandwidth. And so typically what we see is a lot of customers taking advantage of that for workloads that need to happen within a certain time frame, such as backup. Additionally, we have Direct Connect partners around the world who in each individual region will facilitate, you know, in Australia's case, cross pan-Australian connections. And so those Direct Connect partners are the various telcos around the world. I encourage you to check out the Direct Connect site, and there's a link there to the Direct Connect partner network of partners who are able to facilitate connections to Direct Connect and into our Equinix facilities. Okay, that looks to be one more question. Right. How can I concatenate split files that's larger than 5 gigabytes on an S3 bucket? Typically, you need to use your software of choice to do that. We see more application for that in Glacier, where we also have introduced a service called Range Retrievals, whereby Glacier with its tar or zip files enable, obviously with the 40 terabyte archives, to contain a large number of files. And the trick is obviously creating an index to track those byte ranges so that you know when you're getting a whole file or not getting a whole file. So yeah, the ability to do range retrievals means that you're able to also within Glacier stay under the free limit. Every month we offer customers the ability to retrieve 5% of their total archives or total volume stored on Glacier for free, prorated daily. So that means that essentially that works out to be 0.17% of your total vault. And if you've, for example, got 100 terabytes in your vault, that works out to be something like 170 gigabytes per day for free. And you're able to do that and not incur any additional charge. Minimum space for S3, if you use S3 as a mechanism to archive to Glacier, there is no minimum space. Obviously you need to have some objects in there, but you could, for example, if you wanted to have a 100 kilobyte object and then apply the policy to archive that to Glacier. I think that looks to be the end of questions. A quick one on NetApp. Do we have any sync feature with NetApp? Not currently at this stage, though I'm not sure what NetApp are developing at this stage. Certainly they're an ISV partner as well, but I'm not up to speed on what they're currently offering. That looks to be the end of the questions. I'd like to thank you all for your attendance. My email address is there. Feel free to reach out to me directly if required. And I thank you all again for your attendance.
The organizer has